Same way, output resistance. Output side, I'm going to use sampling network. So if I'm going to sample the voltage, I'm going to take across, correct? When I'm going to take across the resistance parallel the resistance will decrease. So remember, when I'm going to use voltage sampling, my output resistance will decrease. When I'm going to use current sampling, the output resistance will increase because current will be same in series. In series, the resistance will increase. When you take output voltage will be, when you take across parallel, resistance will be across. When you take output voltage sampled, the current will reduce, so the impedance will also reduce. So in the inputs, the input side series mixing na resistance will increase, shunt mixing na resistance will decrease. Same way here also, if I'm going to do voltage sampling, output resistance will decrease because I'm taking voltage across the resistance, across nale parallel resistance value korayum. If I'm going to take output current as sample, then it will increase my output resistance because in series, resistance value will increase. But you will definitely know what is the requirement for us. For an ideal amplifier, the input resistance should be very high. The output resistance should be very, very less. So you can choose from these categories what type of amplifier you require for your what amplifier you require for your design. Whether the input impedance should be high or the input impedance should be less, the output impedance should be high or the output impedance should be less. You can decide what type of amplifier you require. I once again summarize. Please understand, when I am going to use series mixing at the input side, my input impedance will increase. When I am going to use shunt mixing at the input side, the input impedance is decreasing. Okay, so same way, when I'm going to use voltage sampling at the output side, the output resistance will decrease. Remember, voltage sampling nale, I'm taking voltage across. Across means parallel. So my output resistance will decrease. When I'm going to take current sampling, current sampling means series. In series, resistance will increase. So the output resistance is going to increase. So this is how you should remember logically what will happen for the input and output resistance when I'm going to apply negative feedback to an amplifier. Is this interpretation very clear to you? Any doubt you have so far? So we have completed the properties of negative feedback. The first half of unit 3 is over. So we need to just discuss about each type of feedback amplifier only. So that will be your second half of unit 3. So second half of unit 3 will be, we'll be discussing in depth about the different 4 types of your feedback amplifier: voltage series, voltage shunt, current series, current shunt. So I'll be saying how you can say the amplifier is voltage series, how the amplifier can be called as voltage shunt, what is the requirement for the amplifier to be called as current series or current shunt. So that I'll be saying, and one example for each we'll be studying. For voltage series, what is the amplifier example? For voltage shunt, what is the amplifier example? So like that, we are going to see for each of the 4 cases. That will complete our unit 3. So for understanding the second half of unit 3, you should know how I am applying feedback and what are the parameters of feedback, which is studied in the first half of unit 3. Okay, so the unit, both the subdivisions of the unit are related. So they are related, and only if you understand the first half, second half will be very, very easy for you. Okay, otherwise, it is going to be very, very difficult. So any doubt or queries you have, you can ask.